square roots of real numbers. In order to study square roots, first we are going to take a brief look on square. Square is a geometrical figure whose all four sides are equal. If we take this small square and length we take as 1, obviously all these other sides have the length 1. So what would be area? Area of square is, as you know, is length times length. So we can say that area is equal to length square. So what would be the area here? If the length of one side is 1, then 1 square is equal to 1. That's area. If the length of this side of the square is 2, obviously this is 2 as well, then what would be the area according to this formula? That would be 4 equal to 2 square. If the length of the side of this square is, let's say, 3, then obviously this side is 3 as well, and the area of this square will be 9, which is in fact equal to length of the side square. So this is 3 square. If we take a look on this pattern, we ultimately get the pattern of numbers like this. 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, and 5 square is equal to 25, because 5 times 5 is 25, 4 times 4 is 16, 3 times 3 is 9, 2 times 2 is 4. Now we are going to carefully take a look the way these relations are named. If you take a look on this last one, 25 is called, how we name it, we say that 25 is square of what? 5. And here we say 16 is square of 4. And here we say 9 is square of 3. And here we are going to definitely say that 4 is square of 2. And obviously this one is going to be 1 is square of 1. But what if we want to reverse this relation? Like we know that how 25 is related to 5, how 16 is related to 4, how 9 is related to 3. But what if we want to know what is relation on the other way around? Like we can definitely say 5 is square root of 25. And this way we can say that 4 is square root of 16. You see how we are naming these relations, just reversing the relation. So 3 is square root of 9, and 2 is square root of 4. Obviously 1 is square root of 1. this is how we name these relations. This, if you carefully take a look on the relation of father and a son, let's say that A is father of B. A relation of A with B is the relation father, but B is what? We can never say that B is father of A, because now reversing the order changes the relation. That's exactly, if you take a look on 25 is square of 5, we can never say that 5 is square of 25. We reverse the order, so now the nature of relation should change. Although there are some relations which can be named the same way, like relation of brother, A is brother of B and B is brother of A, that's right, but not every relation can be reversed. Now we are going to express these relations mathematically. Like mathematics is a language of science which uses symbol, which doesn't have tongue, but it only expresses itself through symbols. So let's say that let's write down how we are going to express this. 1 is square root of 1. How we can express it? 1 is equal to, we use the symbol square root is like this, square root of 1. Okay. 2 is square root of 4. 4 is square root of 2, means, okay, this means exactly same thing. So 1 is just like saying the other. 4 is square root of 2 is square root of 4. So 2 is equal to square root of 4, and 3 is square root of 9. This means 3 is equal to 9 square root. And similarly, 4 is, what did we say? 4 is square root of 16. So we can certainly write it like this. 4 is equal to 16 square root. I hope that you understand what I'm saying. But this form is called radical form. If we want to write mathematically it like this, radical form. The same way we can express in another form, which is 1 is equal to 1 power 1 by 2. So this square root means power 1 by 2. So 2 is equal to 4 power 1 by 2. So this is 3 is equal to 9 power 1 by 2, and 4 is equal to 16 power 1 by 2. This is called exponential form. Exponential form. It doesn't matter whether you write it in the exponential form, or you write it in the radical form, or you write it in this form. All these three mean one and the same thing. So now, what is this symbol? This symbol, the square root symbol. This symbol is called radical sign. Radical sign. And the numbers 1, 4, 9, 16 upon which this symbol operates are called radicand. radicand. So it's clear enough. Now if we would like to practice this in another way, if we say 1 is equal to, if we were talk about the volume of a cube, the cube is like this. Okay, the cube is like this. If we want to make a cube, we make two squares, then join their edges, and now this is a three-dimensional figure in which there is a width, there is length, then there is height, but all of these are equal, just like two sides are equal in square. In this, if we want to calculate the volume of this cube, that would be length time width time height, because each one of the length, the width, and the height are same. So 1 is equal to, let's say that each one is 1, then what would be this? 1 cube. If we take this cube of each side 2, then what would be that? 2 cube would be equal to 2 times 2 times 2, that would be 8. So 27 is equal to 3 cube, and 64 would be equal to 4 cube. Now, just like we did before, here 1 is cube root of 1, and this number 2 is cube root of this number 8, and similarly 3 is cube root of 27, and 4 is cube root of 64. Now we got these English-like statements, and again we can change these statements to into mathematical form, and we will do this. If we want to convert this statement into a mathematical form, we are going to say 1 is equal to cube root of 1. So we can say 1, and this time we're gonna use the same symbol, but because it's cube root, so we're gonna write 3 in this corner here. This is called third root of 1. Similarly, 2 is cube root of 8, so 2 is equal to cube root of 8. So we're gonna write 3 here again, and 3 is equal to 27, and 3 again here, and this 4 is equal to 64, this 3 here. This number which we write in this inside this edge here, that's called the index. So what is the index here in the cube root? That's 3. What is the index here? That's 3 again. What's the index? That's 3. But this is again the radical form, and if we want to write it in exponential form, we can also write it 1, or equivalently we can write it 1 is equal to 1 power 1 by 3. We can write this as 2 is equal to 8 power 1 by 3. We can write this statement in exponential form as 3 is equal to 27 power 1 by 3, and we can write this statement as 4 is equal to 64 power 1 by 3. So I hope you understand this, and now we're going to generalize this idea. If generalization if y is equal to xn, then x is called nth root of y, is called nth root of y, and we can equivalently write it as x equal to y and then the same symbol and n in this corner. Here, what is the index? Index is n. Okay, and n is called the index. Okay, or in exponential form, we can similarly write x is equal to y power 1 over n. So this is, I hope that this will help you to understand how we write and use this symbol in our calculations. And now we are going to describe some of the laws governing the square root operations. And out of these two laws are very important. Well, there are, I'll write all of them here. Well, number one, that square root of a positive number. You can always take the square root of only a positive number. The square root of is always greater than 0. In other words, you can say that a under root is always positive. Number one. Number two, square root of 0 is equal to 0, and there is no other number whose square root is equal to 0. So square root of 0 is equal to 0. In other words, I can write alternatively under root a is equal to 0 if, and if means if and only if a is equal to 0. Like the only number whose square root is equal to 0 is the 0 itself. And third is this, that if you got under root a square, it means under root a times under root a, and this will be equal to a itself. So fourth, and that is under root a will cancel with itself in the numerator and denominator, so this is equal to 1. And number 5, a over under root a is equal to under root a. Like there is half power in the denominator, full power in the numerator, so half will cancel, leaving behind the half power in the numerator. And sixth, we have if you have the half power in the numerator and full power in the denominator, that will give you 1 over under root a. And these two are very, very important. Seventh, if you got a product of numbers or quotient of numbers, let's say a over b, it's perfectly fine if you take the square root of the numerator up and denominator separately. You can take the square root of the numerator and denominator. For example, if you got 7 over 8 whole under root, remember this is all the way down, whole under root is equal to 7 under root over 8 under root. This is very important property that you're going to use a lot in the calculations. That's why I particularly want to emphasize over this thing. And ninth, if you got a product of two numbers, and then you have a square root of the product, you can actually take the product separately, take the square root of each number, time b. And this also is very important, because if you have 2 times 3 square root, you can write it as under root 2 times under root 3. So if it's perfectly fine if you multiply the numbers in the square root sign. So this is these are the laws that will, but these last three properties, I mean 7th, 8th, and one more, that's not the property, but I want you to take a note of this, that a plus b under root is not equal to, you can never write these separately. Remember this. So if you got 2 plus 3 under root, it's not legal, you cannot do this, is equal to under root 2 plus under root 3. You cannot do this. This could be only done, like square root can be separated only in multiplication and division signs. And now we are going to take another approach before we finish this this lesson. We have studied relations and functions in the sets, relations and functions chapter, and there are two kinds of operation. So square root is a unary operation. Unary operation mean that any operation which only requires one number to operate on is called a unary operation, or that operator is called actually the unary operator. If you take a look on positive operation, plus sign will always require two numbers, at least two numbers, 2 and 4, and that will give you 6. That's why plus is called binary operation, because it requires two numbers. And you cannot say, oh, add 4 to what? If you don't tell the second number, the operation of addition is meaningless. That's why the plus is called a binary operation, but the square root is a unary operation. It only requires one number to operate. So if you operate this on 4, it's going to give you the answer right away. It doesn't require the second number. If you operate it on 9, it will give you 3 right away. If you operate it on 36, it will give you 6. So remember that square root is a unary operator, and it only operates on a single number. And if we want to represent this, let's say that we got a Venn diagram. In Venn diagram, if we have a set of numbers which is real numbers, 1, of course there are many numbers others, but 1, 4, 9, 25, 16, 25, and so on, and obviously there are so many numbers in between. But and if they are connected, a function, what is a function? Function is only a rule that transforms number of one set to another set. So if this operation or the operator or the function is a square root, what is one is going to be related to? 1 will be related to 2, 4 will be related to what? 2, 9 will be related to 3, and guess what will be 25 related to, what will be 16 related to, and what will be. And if your answer for this was 5, then you have completely understood the concept. 25, oh, why? Anyways, this is 16 is, we cannot repeat the number, but anyway, 16 is related to 4. So this is how we can simply represent the same in using Venn diagrams. And if you can simply denote this with in tabular form as well, x, y, and this is 1, 4, 9, 16, 25. And what will be if x and y are two variables related by square root, then what will be image of 1? That is equal to 1. 4 is 2, for 9 it's 3. If y is equal to under root x, then x is, so this is y is equal to under root x, so and that is 4, that is 5, and that's how we keep on going. But this opens up another world of numbers and operations. We try, and I know that most of the students are familiar for calculating square root on calculator. They can use Excel and many more options, and we'll discuss that in next lesson.